In this video, we're going to be looking at video solutions to 3 1-mark questions that appeared as a part of the sample paper given by CBSE for Class 10 Maths in the year 2018-19. Question 3 had 2 alternatives. Both these alternatives appeared from trigonometry, and question 4 is from arithmetic progression. So you're going to have video solutions to 2 alternatives of question 3 and question 4. Start with question 3, alternative 1. Write the value of cot square theta minus 1 by sin square theta. In any of these questions, the approach is try and see if you can write all those terms that are given, cot theta or tan theta, in terms of sin and cos theta. Cot theta is equal to cos theta by sin theta. So cot square theta is equal to cos square theta divided by sin square theta minus 1 by sin square theta. So written cot square theta as cos square theta by sin square theta. Sin square theta is a common denominator, so let's take that. So the numerator of this expression is going to be equal to cos square theta minus 1. We know this trigonometric identity, sin square theta plus cos square theta equals 1. So sin square theta is equal to 1 minus cos square theta. Multiply both sides by minus 1. So I'll get minus sin square theta equals minus of 1 minus cos square theta. Minus of 1 minus cos square theta is nothing but cos square theta minus 1. So cos square minus theta minus 1 equals minus sin square theta. So this cos square theta minus 1, let's replace it with minus sin square theta. Minus sin square theta divided by sin square theta equals minus 1. Right? Rather straightforward question. 2 things to know. 1, this we will definitely know. Cos theta by sin theta is equal to cot theta. Second, knowing how to apply this trigonometric identity, sin square theta plus cos square theta equals 1 in this question. Summarize it in a printed form. Writing cot square theta as cos square theta minus sin square theta. The expression becomes cos square theta minus 1 by sin square theta. We know sin square theta plus cos square theta equals 1. So sin square theta equals 1 minus cos square theta. Multiplying both sides by minus 1, we'll get minus sin square theta equals minus of 1 minus cos square theta, which is cos square theta minus 1. So the value of the expression becomes minus 1. The second alternative is also from trigonometry. All of these alternative questions appear from the same topic. If sin theta equals cos theta, then find the value of 2 tan theta plus cos square theta. If we have to find the value of this expression, we need to know what theta is. We need to deduce theta from this information given. We can deduce this theta from this information in 2 ways. When will sin theta be equal to cos theta? Sin theta will be equal to cos theta only when theta equals 45. This is one approach. An alternative approach to getting to this is divide both sides of this equation by cos theta. So you'll have sin theta by cos theta equals cos theta by cos theta. So sin theta by cos theta equals 1. Sin theta by cos theta is nothing but tan theta. So we have tan theta equals 1. Tan theta equals 1. For what value of theta will tan theta be equal to 1? When theta equals 45 degrees. So found out theta equals 45 degrees, which is step 1 of getting to the answer. Let's replace all this theta with 45 and find the value. So trying to find the value for the expression 2 tan 45 degrees plus cos square 45 degrees. Tan 45 is a 1. So 2 times 1 is the value of the left part. Cos 45 is equal to 1 by root 2. We have a cos square 45. So it is 1 by root 2 the whole square. So 2 times 1 is a 2. Excuse me. 1 by root 2 square is a 1 by 2. So 2 plus 1 by 2 is 2.5, which is equal to 5 by 2. So again, a very simple question. The idea is to find out the value of theta using this information and then substitute it with this and finding the value of tan 45 and cos 45 to get to the answer. Summarize that again. We found out the value of theta equals 45 using one of these 2 approaches. So we're replacing this theta with a 45 to get 2 tan 45 plus cos square 45. Tan 45 is a 1, cos 45 is a 1 by root 2. So the expression's value will become 2 times 1 plus 1 by root 2 the whole square, which equals 5 by 2. So move on to question number 4, which is from arithmetic progression. In a very simple question, probably a minute or a minute and a half to wrap it up. If the nth term of an AP is 2n plus 1, what is the sum of its first 3 terms? We're going to do this question in 2 ways. The first approach, we're going to compute the first term and the third term. So there are 3 terms for which we'll have to find out the sum. We're finding out the first and the last term. So A1, which is the first term, is 2 times of, replace this n with a 1 in this expression. So 2 times 1 plus 1, which is equal to 3. So found the first term. Let's compute the third term. A3 is equal to 2 times, instead of n, we'll write it as a 3. 2 times 3 plus 1, which is equal to 7. So you know the first term, we know the third term. Sum of the first n terms of an arithmetic progression. One of the formulae to find out the sum is n times of a plus l divided by 2, where a is the first term, l is the last term. In our case, we are trying to find out the sum of the first three terms. So S3 equals 3 times of the first term, which is A1, the last term, which is A3, divided by 2. Plug in the values of A1 and A3 that we computed. So the sum of the first three terms is 3 times of 3, which is the first term, the last term 7 divided by 2. 3 plus 7 by 2 is a 5. 3 times 5 equals 15. So sum of the first three terms of this arithmetic progression equals 15. Quickly summarize it before we look at the second approach. First approach, we are finding out the first and the last term by substituting n equals 1 and 3 in this formula. Having computed it, sum of the first n terms is n into a plus l by 2. A is the first term, L is the last term, which is A3. So 3 times of A1 plus A3 by 2 gives us an answer which is equal to 15. The second approach is a much simpler approach. What you're going to be doing is we're going to substitute n equals 1, 2 and 3 and compute the first, second and third terms. So if n equals 1, first term is 3, n equals 2, 2 times 2 plus 1, which is 5. We computed the value of the third term in the last approach itself, which equals 7. We know all three terms for which we need to find the sum. Because we're finding the sum of the first three terms, this approach is also equally valid and an easy way to get to the answer. Add these three terms, we'll have the answer to the first three terms. 3 plus 5 plus 7 equals 15. Before you leave, do two things. One, sign up as a user at online.maxtute.com. It's all of 3 steps and less than 5 minutes to get started with your CBSE online class 10 maths coaching. Before you leave, also do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.